All right, we are on relative atomic mass. If you take a look at the warm-up, it says, complete the grocery list by filling in the missing units. Okay, so you have a dozen eggs, 2 liters of milk, and 3 kilograms of flour. From your answer in number 1, what are the 3 ways that we typically express amounts of materials? Well, we have the number of items, we have volume, which is liters, and we have mass, which is kilograms. When we're talking about relative mass, mass is the amount of matter. And when we say that one object has twice as much mass as another, we're expressing the mass relatively. So we say that is the object's relative mass. So we're comparing one object's mass to another's. Now suppose we wanted to determine the relative mass of a staple and a grain of rice. They're both too small for us to get a mass reading on a balance. So what we'd want to do is let's weigh 100 of each. So if we have 100 identical staples and 100 identical grains of rice, you'll find that the staples, the 100 staples weigh twice as much as the 100 grains of rice, which means that a staple will weigh twice as much as 1 grain of rice. And any number of staples will really weigh twice as much as a number of grains of rice. And this works even if the items that are being weighed are not identical. And if we have a variety of pens, you might find that a variety of pens weighs 1.5 times as much as the same number of a variety of pencils. So you would say that the average mass of the pens is 1.52 times the average mass of pencils. So the mass ratio of any equal number of items equals the average mass ratio of those individual items. And when we're looking at the terms weight and mass, the word weigh is sort of serving as it sort of serves 2 purposes. To weigh is to find the weight or compare the weights of. And scales work by comparing weights, so you're by definition weighing objects and materials with a scale. A weighing scale is just a measuring instrument for determining the mass or weight of an object. Technically, the mass never changes whether you're on the surface of the moon or the earth, but weight changes because it's based upon gravity. Let's take a look at the quick check at the bottom. It says, what does relative mass mean? It means one object's mass relative to another's. Number 2, you have 2 bags of candy from a bulk food store, a bag of gumdrops and a bag of jujubes. You intend to determine the relative masses of a jujube and a gumdrop by weighing the contents of each bag. What condition is necessary for this to work? Well, you have to have the same number of candies in each bag. Let's move on to the law of constant composition. In the 1800s, chemists discovered that all samples of a particular compound have the same mass ratio of their constituent elements. For example, 8 grams of oxygen for every 1 gram of hydrogen would be in every sample of water. This is known as the law of constant composition. In 1804, John Dalton argued that the law of constant composition not only supported the concept of atoms, but also provided their relative masses. So if I have one atom of magnesium, it weighs 1.5 times as much as one atom of oxygen. So that means any number of magnesium atoms should weigh 1.5 times as much as any number of oxygen atoms. And let's take a look at a sample problem here. I'm heating 0.35 grams of magnesium powder, and that magnesium reacts with oxygen in the air. I get a compound with a mass of 0.58 grams. It's called magnesium oxide. What is the mass of magnesium relative to the mass of oxygen? So if I've got the mass of magnesium in the compound and I have a compound containing magnesium oxide, if I subtract the mass of the compound and the mass of the magnesium, it will give me the mass of oxygen. So if I want to get the mass ratio of magnesium to oxygen, magnesium is 0.35 grams, oxygen was 0.23 grams. When I divide it, I get 1.52. What that tells me is magnesium atoms weigh 1.52 times as much as oxygen. If we come down here to the practice problems. Number 1 says a dozen identical AA batteries have a mass of 276 grams. A dozen identical watch batteries have a mass of 26.4 grams. The mass of a AA battery is blank times the mass of a watch battery. So we should take the 276 grams of the AA batteries divided by 26.4 grams of the watch batteries. You're going to get 10.5. So that means your AA battery is 10.5 times the mass of a watch battery. Number 2. A sample of strontium oxide is found to contain 2.683 grams of strontium and 0.490 grams of oxygen. What is the mass of a strontium atom relative to the mass of an oxygen atom? So 2.683 grams of strontium divided by your 0.490 grams of oxygen is going to give you a ratio of 5.48. Now, number 3, a 4.218 gram sample of daltonium bromide decomposed, and you have 0.337 grams of daltonium recovered. What is the atomic mass of daltonium given the atomic mass of bromine is 79.9? Well, I've got the mass of my daltonium here, but I need to get the mass of my bromine. So I'm going to take the mass of the compound, which is 4.218, and I'm going to subtract the mass of the daltonium to give me 3.881 grams of bromine. Now, if I want to get the atomic mass of daltonium, I'm going to take my 0.337 grams, let's write this over here, 0.337 grams of daltonium over 3.881 grams of bromine, and I'm going to multiply it by, if you take a look at the atomic mass of bromine here, which is 79.9 U. This U stands for atomic mass unit. Okay? And that will end up giving me 6.94 U. So that is how you get 6.94 for daltonium. Okay? Now, if I look at B, it says this question uses a fictitious element, daltonium, so you can't look up that element's atomic mass. What element does daltonium represent? If you flip to the back of your book, you're going to notice on the top left in the first group, lithium has 6.94 as its atomic mass. So this is representing lithium. Let's turn to the next page. Now, the element hydrogen was discovered to have the least massive atoms. So originally, its atoms were assigned an atomic mass of 1 atomic mass unit, and the mass of all of the other types of atoms were expressed relative to it. And oxygen's atomic mass of 16 really means an oxygen atom is 16 times the mass of a hydrogen atom. So that's why you see here in this figure, I have 1 oxygen atom and 16 hydrogen atoms to give me a countering mass that is equivalent. If you take a look at these practice problems down here. For the sample problem, it says barium chloride has a mass ratio of 1.94 grams of barium for every 1 gram of chlorine. If chlorine has an atomic mass of 35.5, what's the atomic mass for barium? If the formula for barium chloride is BaCl2. So you've got 2 chlorines for every 1 barium. So that means that you would take 1.94, this is the mass of barium, and this is the atomic mass for chlorine. You would have to multiply that by 2, then multiply it by the atomic mass of chlorine to actually get the atomic mass of barium. So you have to double the mass of barium so that you can compare the masses of equal numbers of atoms, okay? So if I look down here at the practice problems, it says aluminum iodide has a mass ratio of 1 aluminum to 14.1 iodine. The atomic mass of iodine is 126.9. What is the atomic mass of aluminum if the formula for aluminum iodide is Ali3? So I'm going to do this one slightly differently. I'm going to take my 3 iodine over 14.100 grams of iodine, and I'm just going to simplify that so it's equivalent to what I have, and then I'm going to multiply that by 126.9, which is going to give me 27 atomic mass units for aluminum. So I simplified how many iodine would be equivalent to 1 aluminum here. Now over here in number 2, I've got 3 iodine, right? And then I've got 2 aluminum. So what you could do is you could still use this 27 atomic mass units, but then what you would do is divide it by 2 to give you 13.5 because you have 2 aluminum in that formula. Now, John Dalton noticed that some of his formulas and the atomic masses were probably incorrect. And in 1860, chemist, an Italian chemist by the name of Cannizzaro, presented a paper where he solved the mystery of atomic masses. So Dalton didn't understand how 2 particles of hydrogen reacted with a particle of oxygen to produce 2 particles of water. He thought that it couldn't happen because you would have to split the oxygen, and he thought it was an atom. But Cannizzaro showed that Dalton's atomic model was still valid if the hydrogen and the oxygen gas particles were made up of pairs of atoms. So we call these diatomic molecules. So di means 2, and there are a bunch of diatomic molecules on the periodic table. So when these elements are pure, in nature they exist as 2 stuck together. So they are iodine, nitrogen, fluorine, oxygen, bromine, chlorine, and hydrogen. Okay, so there are 7 of them. Now, you can either remember this mnemonic, info birch, Or you can look at the periodic table. There's an upside down L that they follow: nitrogen, oxygen, fluorine, and then it comes down chlorine, bromine, and iodine. So this is the upside down L on the right-hand side of the periodic table. And only if you have pure oxygen or chlorine or bromine or any of these, and then hydrogen is off to the left by itself. But if you have any of these in pure form, you have to write a subscript 2 after that. Okay? So Dalton is called the father of the atomic theory because he explained how the law of constant composition provided support for the concept of atoms.